In a previous video, I described some best practices when handling exceptions. In this video, I'm going to do a few demonstrations. So I'll use this inventory reader class that I've been using for a while. And it's a good example for this lecture because it's opening a file. And opening a file means we're reaching outside of the JVM. And these times when we reach outside of the JVM tend to be times when we're going to get a checked exception. So remember, checked exception, we have to do something with it. We either have to rethrow it or wrap it in a try-catch block because those are things that happen outside the JVM, outside the control of our program. On the other hand, an unchecked exception is something that should be prevented from happening in the first place. And I have examples of both. So first of all, the array here is reading from effectively what we're doing is we're reading from this inventory txt file. And each of these has attributes that describe a vehicle. And there are exactly 6 attributes. So in the inventory reader, I'm pulling out those 6 attributes. We start counting with 0 when we're dealing with array indices, so 0 through 5. But first, I check to make sure that there are at least 6 attributes. So that's a case of preventing an unchecked exception from happening, which is what we should be doing. So the concept of the array is within the JVM, therefore it's an unchecked exception, and therefore it's something we should prevent from happening because we have the ability to do that because it's within the JVM. So an easy way to do that is just check for the size before we do the parse. Now I probably should add an else part here and add a log statement that indicates that the array does not have 6 elements. Now, the only trick is I haven't actually read anything in, so I can't really identify where we are, which record we're reading. But nonetheless, warn is good there because it kind of feels weird. We know we should have 6 elements, but we don't. So that's an example of preventing an unchecked exception. Now, the checked exception happens when we invoke this file read all lines. Notice that I start the try immediately before that, which is the best place to put it, but the catch block is all the way down at the bottom. One thing that I see people do somewhat frequently, which is a bad practice, is to take this item that could cause an exception and wrap it just like this. So we basically put the try-catch right around where the exception would occur. Well, this actually is not a good idea in this case because when an exception is thrown, when an exception is caused, it's going to skip every line after that exception until it finds a catch block. And then the catch block is either going to heal the exception if it can, maybe look for a different file or change capitalization or something like that. Or if it can't, it will log the error and then rethrow the error. The important part there is skip all the lines in between. So here's what I tend to see happen sometimes. And this is a really bad practice. But what I'll see sometimes is someone will just leave an empty catch block. Okay, what's going to happen then if there's an exception in reading this file? Maybe that file doesn't exist. Well, the exception is going to be thrown from line 34 down to line 36, and nothing's going to happen. And then the program will resume executing at line 38 because it says, okay, well, the exception was not rethrown. It must have been handled. Now, here's the problem. Line 38 assumes what? It assumes we were able to read this file. So that's why we don't want to put the catch block immediately after the line that might throw the exception. We want to put the catch block after that line, but also we want to put it after any line that is dependent on that line executing successfully. And so that's why I'll go ahead and Control Z here. That's why the original place where I had the exception was after we read and parsed the file. Now, we also don't want to put the exception, the catch block, any lower than it needs to be. It should just be wrapped around the line that might throw the exception and all of the lines that are dependent on that executing properly. We don't want to just put all the way at the bottom of the method because there could be other unrelated things that we need to do. Let's go ahead and see how this works. I have named the file inventory2.txt where the actual name is inventory.txt, so I know that this will throw an exception. So I'll just snap a few breakpoints here and then run inventory reader in debug mode. Now watch very carefully here we get a reference to the file that does not exist, and now we try to read from a file that does not exist. Now here's where I really want you to pay close attention to what's going on. Step over, or F8, means execute this line and run to the next line we can execute. What's going to happen here is on line 34, it's going to throw an exception that says file not found, and it's going to skip all of these lines in between and take us right down here to this catch block. So let's watch. And sure enough, you see it goes straight to the catch block, which means it did not process these lines in between, which is the whole idea, because the only reason we would want to process these lines in between is if we were successfully able to read from the file. Now, let's consider a few other best practices. In a catch block, we should never return null, because then we take what could be a very informative exception, we throw it all away, we return null, which more than likely is going to cause a null pointer exception in the future, and we're not going to know why. So, okay, we take a look at my catch block, and am I returning null? No, I'm not. Next best practice, we should always log in our catch blocks, even if we don't think we have to. And we should log at the right level, which more often than not is error, could also be fatal, maybe could be warned. So I do have logging set up here, and I set that up in a previous video, so I'm going to say, okay, we're good there. Now, here comes a tricky part, but an important part. Let's remember this flowchart from that presentation I had. This is discussing what do we do in a catch block. So can I handle it locally? Is there some way I can heal it? Let's say, in this case, maybe I say, hey, can you give me another file? Or maybe there's a series of files that I could read from. This one didn't work, but I could try another one. Well, if that's the case, then use a try catch block, heal it in the catch block, and we're done. I don't think I'm going to have that option in this case because I'm just, I've hard-coded that file. So we probably want to look at our other options. Next, if I can't heal it locally, that's not an option. Ask myself, am I in a user interface layer? Well, in this case, I'm not, because I'm just reading data from the file. So in that case, I'm going to throw the exception. And that means that someone else, whoever called me, is going to need to catch that exception. And then they'll go through the same flowchart, and if they're in the UI layer, then they have that opportunity to show a brief error message to the user. So in this case, it looks like I am rethrowing the exception, and I actually wrap it as a new runtime exception. That's a little bit dirty because runtime exception could be an unchecked exception. The other thing is, I kind of frown on a catch block that just rethrows the exception. If it's just rethrowing the exception, the truth is we could take the try catch out totally and just add throws exception to the method signature and let the exception naturally throw itself. But nonetheless, let's go ahead and just, I'm going to say throw E, which basically says we've caught the exception. Now we're going to rethrow the exception. Now the important part here is that it's going to terminate this method once we throw the exception. So if there is anything after this, it's simply not going to execute. Now you notice that I get a red line here and it says unhandled exception, Java.io exception. Well, I need to add a statement to the method signature to say throws exception. That basically tells the calling method that an exception might be thrown here, and what are you going to do? And as a matter of fact, let's look at where this method is called. It's called in two places. One of them is right here in Inventory Reader, and you can see that it's actually already warning us. It says, okay, well, this could throw an exception, so once again, we can do a try-catch block. I can Alt-Enter, say surround with try-catch. Okay, now I've given it a try-catch block. Now let's remember our golden rule. Where does the catch block end? It should end after anything that is dependent on this executing successfully. So run vehicle is only going to work if we can create a vehicle. So I'm going to take that run vehicle and put it right up here in this try catch. So if there is an exception in create vehicle, it's going to skip run vehicle entirely and come to this catch block. In this catch block I can just do, guess I could log, yeah. I mean, there's really not a whole lot I can do. I could prompt the user and say, hey, something didn't work, or I could just log it. And there we go. But that will terminate the program because we don't have a valid file. Now, we know that we have two usages of this. The other one is driver form. You see, in driver form, we're invoking inventory reader.createVehicle. And that is here in our constructor. So what I could do is wrap this in a try-catch and inform the user. Now, incidentally, our program is still functional if we're unable to read this file. This file contains some pre-populated vehicles, but we could still use the interactive user interface to add any vehicles of our choosing as well. So I'll just go ahead and wrap this in a try-catch. And instead of throw new runtime exception, of course, let's log. Ooh, I need to bring my log statement over, don't I? Log the error and then tell the user that something went wrong. We don't want to show the entire exception to the user because it might confuse the user. It might give the user technical details the user doesn't know about. Or even worse, it could be that the user is trying to find those technical details because the user is trying to compromise our system. So let's keep it short and sweet. Let's go ahead and log the error. And then let's just say unable to read the inventory file. But, you know, we can still keep going here, right? We can still work with this because we can still add things in interactive mode. Let me go ahead and run this in the debugger. And we see it starting to start up our program. Now it's getting our inventory record. Notice we're an inventory reader. And it's going to log this exception and then throw the exception back. Now when it throws the exception back from inventory reader to driver form, note what happens is we end up in this catch block. And then the error message pops up. It came up on my other monitor, but I can move it over here. You can see it, unable to read inventory file. And then we simply continue and we go ahead and draw the user interface because we know that, okay, well, that was not an essential function. We can still operate without. Now that we've seen how the try-catch block works, you might figure out that it's basically an if test. It's saying, if our risky behavior succeeds, which is this line right here, then all of this will execute. This will not execute. On the other hand, if our risky behavior fails right here, then all of this will not execute, which again is very important what you choose to put there. Put things in there that are dependent on that line being successful. However, this will execute. So it's essentially binary. One or two of these things will execute, but not both. Unless another identical exception happens to be thrown later, which is unlikely because this is an I/O exception. So a couple of things we can consider here. One is we can have multiple catch blocks to catch multiple exception types. And so I could do a catch like so, and then say exception E. And exceptions have an inheritance hierarchy just like a normal class. So exception, just that word exception is fairly high up in the hierarchy, where I/O exception is essentially a subclass of exception. So when an exception is thrown, it will be caught by the first block that fits that exception's inheritance hierarchy. In other words, if I have an I/O exception, it's going to be handled by this block, and then this block will be skipped because only one catch block will handle it. On the other hand, if I did get an array index out of bounds exception, it would skip this block because an array index out of bounds exception is not an I/O exception, but it would be cut by this block because exception is essentially a grand superclass of a lot of our exceptions. Now, there's an interesting distinction here. You notice that class exception is essentially the grand superclass of all exceptions. It has one subclass called runtime exception, and those are unchecked exceptions. Unchecked exceptions are the ones that we should prevent from happening as programmers because they tend to happen within the Java virtual machine based on the code that we write. So example, null pointer exception, that's an unchecked exception. We should prevent it from happening. Null pointer exceptions when you declare a variable and you don't put an object inside of it, and then you try to invoke a method on that variable and there's no object to invoke the method on. So we should prevent that from ever happening. That's unchecked. Another one is a class cast exception. That's when your object type is dog and you try to cast it to a cat. These things are dissimilar, so we get a class cast exception. You can easily prevent that, number one, by avoiding the cast totally by using things like generics or just using good polymorphism. But number two, if you have to cast, do an instance of first. So if an exception extends from runtime exception, then it is an unchecked exception. Now, you notice that runtime exception actually itself extends from exception. So I have to make a little distinction here when we look at exception, because everything except for runtime exception in this direct known subclasses is a checked exception. And remember that a checked exception is typically something that happens outside the JVM, like trying to access a file, trying to write to a database, things like that. And because they're somewhat outside of our control, because they're outside of the JVM, we're forced to handle them. And by handle them, I mean we either have to wrap the statement that could throw an exception in a try-catch block, or we need to add the throws exception clause to our method signature to indicate that we might rethrow an exception that we receive. So checked exceptions we have to handle. They occur outside the JVM. They are subclasses of class exception except for runtime exception. Unchecked exceptions are things we should prevent through good coding, and those are the ones that extend from runtime exception. Nonetheless, this hierarchy is really important, and it's important that we put things in the right order. Because remember, I mentioned an exception is going to be handled by the first catch block that applies to its hierarchy. So IO exception and all of its subclasses will be handled by this. But anything that's not an IO exception will be handled by this. Now, what if we switch these around, though? This is where things get interesting. What if I move my catch block for this one up above the catch block for IO exception? Well, in that case, notice what happens. We get a really interesting red line here. Exception Java IO exception has already been caught. And why is that? Well, remember that IO exception extends from exception. So if an IO exception occurred, it would look at this and say, okay, yeah, I'm an exception. That's in my superclass hierarchy. This is going to catch it and handle it. This will never get invoked. So typically when you're arranging catch blocks, you want to go from the most specific subclass at the top to the most general superclass at the bottom, and the exception will simply be caught by the first one that applies. So by putting the most specific at top, you can handle that one very specifically. And then by the time you get to the all-purpose exception, it's just like at that point, well, it could be anything, I don't know, so I'm just going to handle this in a generic manner. So, can't have multiple catch blocks for a try, and it's important that you put them in order from the most specific subclass at the top to the most general superclass at the bottom. And only one catch block will execute. So, for example, if we go back to the way we had this just a moment ago, if I threw an IO exception, it would get handled by this handler right here, and this handler would never execute. Now, one more thought. So I mentioned this is like an if test, where we have line run successfully, all of this executes, and the catch blocks don't fire. On the other hand, if the line does not run successfully, if that file doesn't exist, for instance, then none of this blue will execute, but instead the first catch block that applies will execute. Well, there's one more that we can take a look at, and I'll tell you what, I'm going to get rid of this. Yeah, I'll just keep that there. We'll put a log statement in there. Kind of corny to have the exact same behavior in two places, but nonetheless, yeah, we get the idea. We know what these are for. Now, there's one more thing, which is a finally block. And while up above we essentially have an if test that's occurring with these exceptions, finally will always execute, whether an exception was caught or not. The finally will always execute. A lot of times we'll use this to do things like close any resources that we have, so any database connections we have open or any file handles we have open, we can clean that up in a finally. There is a new feature on try-catch blocks as well, which is try with resources, which is designed to do that up front. We'll explore that a little more when we look at file I/O, but yeah, try with resources works when you have a resource you need to close. Finally block is another way to do that, or another way to do some kind of housekeeping. So with all that being said, let's go ahead and run this one more time. I'm going to keep the invalid file here so that we can watch what happens when we have an exception that's caught. We can watch which of these blocks handles the exception, and we can also, I'll stick a breakpoint there in the finally. We can also watch the finally and see that execute. So reading the file that doesn't exist, actually getting a reference to the file that doesn't exist. Now we're trying to read records from the file that doesn't exist. And just like before, I'm going to continue to use step over, which means execute this line and go to the next. And what you'll see is that indeed we do not execute the very next line, because this is essentially an if test. It's going to take us right down to the catch block. And notice which catch block? The IO exception catch block. And then we're going to throw the exception up to the calling method, but first, notice we're going to jump in that finally first. So we're going to jump in the finally, handle it, and then we throw the exception back to the calling method, and then we let the calling method handle it. So just for grins, let's go ahead. I'll tell you what, I'm going to run this a couple more times. I'm going to run it with the valid file, and we'll see that the finally block will execute again. Okay, so see step over, step over. Now we're walking through this part because we have a valid file. It's going to read several different records, so I'm just going to go ahead and do a run to cursor. And you notice that none of the catch blocks stopped at a breakpoint because nothing went wrong. However, we do now have the finally, and we tell it, okay, we're all good. Please continue. One more thing I want to try now. Let's go ahead and try for a runtime exception, which remember, that's the exception that should never happen. And for that, it should never happen because we should prevent it by being good programmers. For that, I'm going to go ahead and access an element from inventory array that does not exist, and that will throw an array index out of bounds exception, which is not an IO exception, so it will skip the catch, the IO exception catch. It will go to the general exception catch, and then it will go to the finally. Let's go ahead and try this one out. Read from the file, that's good. We know it's a valid file, no problem with that. But we also know that inventory array has only 6 elements, not 7. And we're going to try to access element number 7. And you see that our IDE already tells us this is going to throw an array index out of bounds exception, which means it's going to skip the rest of this block. And where's it going to go? It goes to the general all-purpose exception block. We rethrow the exception, but at first we hit the finally, and then we throw the exception. So, in this video, we have seen some best practices around exceptions. Catch blocks should never be empty. They should never return null. At the very least, they should log the statement. We also know there's a bit of a hierarchy to decide what we want to do in a catch block. Can we heal it locally? Let's go ahead and heal it locally and move on. If not, are we in a UI layer? If so, display a simple message to the user. If not, keep throwing the exception back until we reach a UI layer, which more than likely we typically will. We know exceptions. We want to think about where the try goes and where the catch click goes and make sure that anything that's dependent on that risky behavior is within that try catch block, because as soon as the exception is thrown, it's going to go to the catch block and skip all the lines in between. Or if there is no catch block, there is no try catch, it will simply rethrow the error back to the calling method. Exceptions are really important in Java, and so I certainly hope that you found this video helpful. And as always, I look forward to reading your comments. Thank you.